Hello, Integrated Math 1. Welcome to Module 2, Topic 3, Lesson 1. We're doing Part A. We're doing the first day of this. We have split it up a little bit. It's just a bit much to do all in one day. So we've already been talking about our athletic association and how they're trying to sell tickets and make $3,000. And we already came up with a lovely equation to help us do that. So considering that goal of the athletic association that we did in our Getting Started activity, we're going to let S represent the number of student tickets sold, and we're going to let A represent the number of adult tickets sold. And so written in standard form, which if you recall, that's the whole AX plus BY equals C, right, where they're constants and we don't deal with fractions and there's no zeros, like everything's lovely. Written in standard form, the equation that represents a situation is 5S plus 10A equals 3,000 because it was $5 for each student ticket, $10 for each adult ticket, and $3,000 overall is what they were trying to make. So let's see if we can actually use this formula to get some information. And one of the things we want to do is graph it. And in a very efficient way to graph one of these, we liked graphing stuff when it was in slope-intercept form, but an efficient way to graph things when it's in standard form like this, an efficient way to graph a linear function in standard form is to use x and y intercepts. And we talked about this a lot before. We talked about it in the last unit. We talked about it in the unit before that. We've been coming up with this. Remember that you can calculate the x-intercept by substituting y equals 0 and solving for x, and that you can calculate the y-intercept by plugging in x equals 0 and then solving for y. So you can plug in some zeros and figure out what your intercepts are. So that's what you're going to want to do here. Number one, you're going to want to find your x-intercepts and y-intercepts. And looking at how they wrote the graph, I'm going to use that information. Notice how it looks like our x-axis is our student tickets sold. So I'm just going to make a little note here that this is my x. And it looks like my y-axis is labeled as adult tickets sold. So it looks like my y is going to be my A. So you can think of them that way. If you even wanted to put X's and Y's in there, I suppose you could. I'm going to keep them as S's and A's, though, to make it a little bit easier on me. But go ahead and plug in a 0, find your x-intercept, plug in a 0 for x, find your y-intercept, find your intercept. And once you've got your intercept, plot them on your x-axis, plot your y-intercept on your y-axis, and then connect the dots to graph the equation. Go ahead and hit pause to work this out. It's not that bad. And then hit play when you're ready to check your work. So we said S was our X, right? So I'm going to start with that x-intercept. If I want to find out what my x-intercept is, I need to plug in a 0 for A. So I plugged in a 0 for A. And then this was actually pretty easy because, of course, 10 times 0 is 0. That just like cancels off and dies. So I have 5S equals 3,000. And if I divide both sides by 5, I find out that S is, I need a calculator. I believe it's 600. Thank you, calculator. That's always a good thing. So it looks like my x-axis is 600. I'm going to erase these and put a prettier version up so it's easier to read. There we go. And if we want to find the y-intercept, well, that means I need to plug in a 0 for S, right? I need to plug a 0 into the other guy. So 5 times 0 plus 10a equals 3,000. Of course, the nice thing is that 5 times 0 is 0, so it's like gone, which is very nice. 10a equals 3,000, so you can divide both sides by 10. You find out that a is 300. And then all you need to do is plot these. Our x-intercept, our s-intercept is 600. So that means, there's 400, there's 800. It looks like we're counting by hundreds. So it looks like I need to put a dot right there at 600 on my x-axis. And that means I need to put a point at 300 on my y-axis. So here's my y-axis again, 1, 2, 3. Put a dot there. Grab a straight edge and connect the dots. La, la, la. Connect the dots. La, la, la. Oh, look, you graphed it. Good job. Wow, that actually wasn't bad at all. So this is actually a super nice way of graphing equations in standard form. Find your intercepts, right? Find your x-intercept, find your y-intercept, plot the points, connect the points. It's all good. Let's get a little more in detail here, though. We're asked to describe the domain and range. For part A, we want the domain and range of the mathematical function. So remember, when you're talking the function, look at this line. It's nice and solid. It goes, has arrows on both ends, always important. Remember that domain is all the possibilities for x. What can I plug in for x? And range is what can I plug in for y. So if I'm just looking at the equation, nothing fancy. If I'm just looking at the equation, 5a plus 10s equals 3,000. And let's say I didn't even know the situation. I just was given this equation. What can you plug in? That's going to be your domain. And what can you possibly get out? That's going to be your range. Go ahead and hit pause to work this out. Put down your thoughts on this and then hit play when you're ready to check your work. So domain is input, right? That's my X. That's what I can plug in. And if you look at this is a nice solid line. There's no holes in it. It goes forever to the right. It goes forever to the left. So my domain for the function is all real numbers. My range is my output. That's my Y, so that's up and down. And if you'll notice, again, it's nice and solid, no holes, no blips. It goes up forever, it goes down forever. So my range for my function is also all real numbers. Now, if that feels a little strange, it should, because this function is modeling a real world situation. So where did this equation come from, people? Give some thought as to what A is, give some thought to what S is, what those variables are and what they mean in the real world, and then tell me what my domain is and what my range is. What's my possibility for student tickets sold? What are my possibilities for my adult tickets sold? Go ahead and hit pause and write down your thoughts, then hit play when you're ready to check your work. So my domain is my X, that's my student tickets sold. So when we're talking about S, when we're talking about student tickets sold, there's no negative tickets. I don't know how you would sell negative tickets. That would be weird. There's also no pieces of tickets, right? You sell a ticket or you don't sell a ticket. There's no in between on that. And these are backwards, aren't they? That's supposed to be an S and that's supposed to be an A. Naughty book, writing it down wrong. So you either sell a student ticket or you don't sell a student ticket, but you also can't have negative tickets. So that means I can go from 0 to 600 tickets sold. Because again, we don't do the negative thing. We don't do the negative thing. It also means it can only be whole numbers. So that means my domain of the real world situation is all whole numbers. And that should say numbers. It only says number, doesn't it? Hang on, I can fix it. I can fix it. I can. Whole numbers. There. I fixed it. Okay. So my domain is all whole numbers that are between 0 and 600. I can sell 0 student tickets. I could sell 600 student tickets. I could sell anywhere in between that, but that's it. And it also has to be whole numbers, right? I can't be selling 2.5 tickets. That doesn't work. You sell a ticket or you don't. That's also going to be true for a range then, isn't it? For our adult tickets, only it's a little bit different. I can sell as few as 0. I can sell as many as 300. But again, since we don't do the negative thing, that's kind of where we max it out. So that means my adult tickets also have to be whole numbers. You sell a ticket or you don't. So my range of the real world situation is all whole numbers such that A is between 0 and 300. And I could sell 0 adult tickets. I could sell 300 adult tickets. I could sell any combination in between as long as they are whole numbers. Because again, you don't really sell pieces of tickets. That's weird. So we found these intercepts, right? We found that our x-intercept was 600 and that our y-intercept was 300. Sorry, I want my pen here because again, they mess it up. That should be 5S and that should be 10A. There's a typo in the book. I'm so sorry. And it's so angry at me that it won't even let me fix it. So explain what each of these intercepts are. We found our x-intercept earlier. We found our y-intercept earlier. what do they mean in terms of ticket sales in this whole situation? Go ahead and hit pause and write it down, and then hit play when you're ready to continue the discussion. So the x-intercept is 600, right? It's at 600, 0. That means that if I sell 600 student tickets, I wouldn't have to sell any adult tickets. So the x-intercept represents the number of student tickets that you would have to sell to reach $3,000 if you don't sell any adult tickets at all. Well, that means then that our y-intercept, which is at 300, so it's 0, 300. Oh, so that means the y-intercept represents the number of adult tickets that must be sold to reach $3,000 if no student tickets are sold. So 0 student tickets means I better sell 300 adult tickets so that we can meet our goal of $3,000. Yeah. All right. Now I'm going to challenge you. I'm going to make you think. I'm going to make you work for this one. I would like you to find the slope of the function. Find the slope. Rise over run, a lot of ways of doing it. There are many ways of finding the slope of this function. And again, this is so naughty. It's going to drive me crazy. I'm going to fix it like every time, aren't I? Stupid typo in the book. So find the slope. And once you've got the slope, tell me what it means in terms of these ticket sales situation. Go ahead and hit pause, see what you can do with it, and then hit play when you're ready to check your work. Now, the method I'm about to show you is not the only way of doing this. There are many other ways that you could have found the slope, but I'm going to show you just the way that I did it. I am also going to point out that notice how this is going downward. That's a clue to us that our slope is negative. So whatever happens, we know we should be getting a negative slope. It's moving down, people. So the way I'm going to find the slope is I like that whole slope-intercept form, y equals mx plus b, and I'm like, there's my slope. There's my rate of change. So I'm going to go ahead and solve for a. I'm going to get my a all alone on his own. So in order to do that, I'm going to use another color, by the way, to make it easier for you to see here. I'm going to go ahead and subtract 5s from both sides. Trying to get that a all alone so I can find my slope. Now I have 10a equals negative 5s, and that's a positive 3,000, so I'm going to put plus 3,000. Still don't quite have my a alone, so I'm going to divide everything by 10, divide by 10, divide by 10, so that those will cancel out. And now my a is all alone. Now I do need to clean up over here. 5 tenths, that's half, right? 5 is half a 10, so that's a negative 1/2 s plus 3,000 divided by 10. If you have a calculator, always useful, it gives us 300. So it looks like my slope is negative 1/2. Hooray, there it is. But what does it mean in terms of this situation? Let's talk. In fact, I'm going to go ahead and erase all of this so we can see a little better. So the slope of the function is negative 1/2. So what does that mean in terms of ticket sales? Here's what it means. It means that for every 1 adult ticket sold, 2 less student tickets need to be sold. If I sell 1 adult ticket, that's 2 fewer student tickets that I need to sell to reach my goal. That's what that slope means, sure enough. So how can we use this graph to determine what combinations of ticket sales would meet our $3,000 goal? Hit pause, give it some thought. How is this graph helping us figure out how to meet our sales goal? Jot down your thoughts on that, and then hit play when you're ready to keep the discussion going. Now, first of all, if you remember our domain and our range for the situation, we said that really, and again, sorry, that's driving me crazy. I gotta fix that. That's, that's an S. That's an A. It's super annoying. So remember what we said with our domain and range? That really, we're only looking at this chunk, right? This is all we're actually looking at. So really, this means that any point on that line should give us the right combination of ticket sales. Now, I will warn you. Remember that we also said they had to be whole numbers. So this is going to be a long explanation of putting all this together. I can use any point on this line that's within the domain and range. So it's on this chunk that has an X and Y value that are whole numbers, okay? And any point I pick within this little chunk that would give me a whole X number for X, a whole number for Y, would be a possible combination of ticket sales that would help us meet our $3,000 goal. Yay! But of course, there are many ways of solving this mess. So here's Felino. Felino also graphed the equation 5s plus 10a equals 3,000. He graphed it too, but his graph is different than ours. Why is that? Explain why Felino's graph is still correct, because this graph looks really different than the one we just made. But why is his still correct? Hit pause, jot down some of the things you're noticing here about Felino's graph and how it may be different from our graph, and then hit play when you're ready to continue the discussion. So I noticed a few things. So Felino's graph is correct, just so we're clear on that. But one of the first things I noticed was that our x-axis, our independent variable, was the student tickets. But check it out. Felino's independent variable is the adult tickets. And for us, our dependent variable, our y, was adult tickets. But for Felino, it's the student tickets. So Felino's graph is still correct. He just reversed his independent and dependent variables. So he let the x-axis be adult tickets and the y-axis be the student tickets. So it's just reversed from what we did. That's all. But that means that it also reversed the x and y intercepts. So our x-intercept was 600 and our y-intercept was 300, but check out Felino's graph. His x-intercept is 300 and his y-intercept is 600. So he just flipped things, that's all. Because he switched his x and y, it means he also switched his x and y intercepts, and it still works, this is still accurate, but it definitely changed a few things. So let's take a closer look. What can you tell me about the domain and range of the mathematical function? If you didn't know that this was about ticket sales, if you're just looking at our lovely graph here, tell me about the domain and range. Go ahead and hit pause, jot down your thoughts, hit play to keep the discussion going. So just like before, the line is solid, the line goes forever to the right and forever to the left, so the domain of the function is all real numbers. Just like before, my line is solid. It goes with those arrows forever up, forever down. The range of my function is also all real numbers. So it's similar to what we had before. But now let's talk about the domain and the range of the real world situation. It shifted a little bit. You might want to go back and look at what we wrote down about the domain and range of our real world situation before. How has it changed now on Felino's graph? Use that to help you figure this out. Go ahead and hit pause to give me the domain and range of the real world situation of Felino's graph, and then hit play when you're ready to check your work. All right, here we go, people. So here's Felino's graph. It's very lovely. It's very pretty. Notice the domain, and again, we don't want to deal with negative stuff. So the domain is only going to go from here to here, right? I mean, that's it. Oh, and also you sell a ticket or you don't sell a ticket. So that means no decimally fractiony stuff. So our domain for the real world situation is all whole numbers. And again, why is my grammar so bad? I'm just going to put an S there, numbers. is all whole numbers such that 0 is less than or equal to a is less than or equal to 300. So our domain is any whole number from 0 to 300. And that means that our range, then, that's our uppy downy guy, right? It's going to go from here all the way up to here. So do. Oh, helps if I write it. All right, there we go. So here's our, this is our range here, right? That's our y. So that means that the range of our real world situation is, again, all whole numbers. Put my S in there. Sorry for the bad grammar. All whole numbers from 0 to 600. So what happened here? We'll get there in a second. What are our new intercepts now? We actually mentioned this a little bit before, but go ahead and explain what each intercept means in terms of the problem situation and the way Foligno graphed it. What are the intercepts and what do they mean now? Go ahead and hit pause to write it down. We did something similar earlier. Hit pause to write it down and hit play when you're ready to check your work. So the x-intercept, that's this bad boy. It's 300, right? So the x-intercept is now 300, 0. And so that means, since our x is our adult tickets sold, that means the x-intercept represents the number of adult tickets that must be sold to reach $3,000 if no student tickets are sold. Our y-intercept is up here at 600. So the y-intercept is at 0, 600, which means because y is the student ticket sold, so the y-intercept represents the number of student tickets that must be sold to reach $3,000 if no adult tickets are sold. All right. Identify the slope. Go ahead and hit pause. We did something very similar before. Hit pause to work it out. Hit play when you're ready to check your work. Now, notice something here. Remember that I like to find slope, and again, it's not the only way, but I like to find slope by doing y equals mx plus b. But remember how Foligno swapped things around. My y is now the student tickets. So that means that s is now my y. So I need to get the s all alone. So I'm going to subtract 10a from both sides. Again, this isn't the only way to find a slope, but it's a way of finding it. Do you get it? A way of finding it. So there's 5s, and I have negative 10a, and that's a positive 3,000. So I'm going to put plus 3,000. Sorry, my bad handwriting. That a is a very sad-looking a. Of course, I need to get s alone, so I'm going to divide everybody by 5. They all get it. So we have s equals, well, negative 10 divided by 5 is a negative 2, so I have negative 2a, plus 3,000 divided by 5 is 600. You can use a calculator if you need to. It's cool. Ooh, there's my slope. So my slope is negative 2. So what does that mean? Oh, that's the question. What does it mean? I'm going to erase all this. So what this means for us, the slope of my function is negative 2. So that means that for every 2 student tickets sold, 1 less adult ticket needs to be sold. That's, again, negative slope. We knew it was negative. It was going downhill no matter what we did. Excellent. That's nice. So I'd like you to do some comparisons here. We did the domain and range of the real world situation. We did it originally, and then we did it again with Foligno's situation where he'd swapped his independent and dependent variables. Can you take a look at those and compare them and tell me what you notice? Go ahead and hit pause, write it down, hit play when you're ready to check your work. I hope you noticed that the domain and range were switched. Yeah, the domain of the first function that models the real world situation is the range of the second function that models the real world situation. And the range of the first function that modeled the real world situation is the domain of the second function that modeled the real world situation. So this is a fancy way of saying, dude, the domain and range are switched. What about the X and Y intercepts? What did you notice happened to those? Hit pause, write it down, hit play when you're ready to keep the discussion going. I hope you noticed that they were switched too. Yeah, the intercepts are also switched. That our original x-intercept became the new y-intercept, and our original y-intercept became the new x-intercept. Does it matter, though, which graph we use? That's the real question here. Does it matter which graph we use, the original graph we made or the one Foligno made? Tell me why or why not. Go ahead and hit pause, jot it down. Yeah, it actually doesn't matter which graph you use, guys. Either way, the group's going to raise $3,000 for any ordered pair that's on either graph. It really doesn't matter which one you use. They will both hopefully help us reach our goal of $3,000. But let's take this. So they've done their sales, and here's what they found. Activity 1.2. The athletic director of Marshall High School Athletic Association says, hey, 450 total tickets were sold to the home game. Great. So 450 total tickets. We don't know how many of those were student tickets, and we don't know how many of those were adult tickets. So let's see if we can figure this out. First of all, write an equation that represents that situation. If we have S, again, S will still be the number of student tickets. A will still be the number of adult tickets. We know we've sold a total of 450 tickets. Can you put those together in an equation for me? Hit pause, write it down, hit play when you're ready to check your work. So student tickets plus adult tickets tell us we got 450 tickets. So I just wrote S plus A equals 450. I felt like I could do that. So here are our graphs from before. So these are the graphs from before. This is the one we originally made in the other activity. This is the one Foligno made, and we were like, they both work, they both do the job. We just flip some things around. Here's what I would like you to do. I would like you to use X and Y intercepts to graph our new function. This guy, right? S plus A equals 450. Remember how last time we plugged in the zeros to figure out what our intercepts were? I would like you to do the same thing here. I'd like you to plug in zeros, find your x-intercepts, find your y-intercepts, and put them on both graphs. So pay attention whether it's student tickets or adult tickets, okay? Go ahead and hit pause, see if you can work this out, and then hit play when you're ready to check your work. So to make this easier for me, because the X's and Y's were swapping all the time, is I referred to them as an S-intercept and an A-intercept. It just helped me put things on my graph. So for my S-intercept, I need to take my S plus A equals 450. If I want S, I have to plug in a 0 for A, so I did that. Of course, S plus 0 is just S, so it looks like my S-intercept is 450. Which means that my A-intercept, well, if I want to find A, I need to plug in a 0 for S. So 0 plus A equals 450. Oh, well, 0 plus A is A, so A equals 450. And we need to put these on our number lines. So my S-intercept, for this first graph, it looks like my X is my S-intercept. So I'll put a little 450, need a little dot there. On the other graph, though, my S is the Y guy, so I'll put my 450 over here. Except my pen doesn't want to work. My A-intercept, oh, it's also 450. So for Y, adults are Y here, so 450 will be right about there. And X is my adults over here, so 450 again, be right about there. And of course, you need to use a nice straight edge, connect your dots, use a nice straight edge to connect them. Boom, you've graphed them. Do you notice something? Do you notice something? I noticed something. I'm going to make a note of it. They kind of smack into each other here, don't they? Do you see that? Okay, these are not my best graphs. These are not good graphs at all. Hopefully you used a straight edge and you did better. But notice they intersect, right? They both have lovely intersections. So you might want to look at those intersections. If the Athletics Association reached its goal of $3,000 in ticket sales, how many of each type of ticket was sold? And is there more than one solution here? Hit pause, take a close look at those graphs and where they intersect. Hit pause, take a look at where they intersect, write it down, and then hit play when you're ready to check your work. So my graphs are not the best graphs I've ever drawn, but you can see here, it looks like we're at 300 here. I come down and it looks like we're at about 150 over here. And in fact, if I come over here, it's kind of a hot mess, but you get the idea. It looks like, oh, it's kind of shifted over. This is not my best one. But you get the idea. Looks like it hits at about 150 over here. And this is not a good drawing. Pretend I did it better. Looks like it hits at about 300 over there as well. Ooh, interesting. So it looks like, paying attention, it looks like it keeps hitting 300 on my student tickets and 150 on my adult tickets. So it looks like there should be 300 student tickets and 150 adult tickets sold if we did in fact meet our goal of $3,000. And there's only one solution because there's only one point on the graph where they intersect. So there is only one solution. That's it. No more, no less. Of course, if you wanted to be more precise, you totally could have used Desmos to do this. You could have put your equations in general form and slope-intercept form. We actually already did that for the first one when we did a equals -1/2 s plus 300. We did that earlier. And of course, you could do it again for this guy as well. You could be like, forget this, man, I'm getting a alone. And you could subtract s from both sides, and you get this bad boy over here. So you totally could have taken these guys and you could have graphed them in Desmos. And then you would have been like, look where they intersect. Remember how magical Desmos is that you can just tap it and you're like, oh, that's the intersection point. And you could totally double check that with some technology. So graphing it is actually really nice because you can see where they intersect, which is also why it's nice to use Desmos and technology other than my sketchy ghetto graphs that we just did. But you can see where they intersect and it'll actually tell you how many of each kind of ticket you have to sell. There is a way to prove this algebraically as well. Again, if we get them into the slope-intercept form, the general form, get our A's all alone, well, if they're both equal to A, shouldn't these be equal to each other? Go ahead and do the algebra to solve this, and then hit play when you're ready to check your work. So for me personally, I don't like the 1/2 thing, so I just multiplied everybody by 2. I was like, forget this bad boy. I'm going to multiply everything by 2. It just made it easier because the 2 and the 1/2 will cancel out. 2 times 300 is 600. That becomes a -2s, and 2 times 450 is 900. So I just found it was easier if I just did it this way. I don't like having s's on both sides. That's no good. So I'm going to go ahead and add 2s to both sides. But of course, when I do that, 2s minus s is just 1s. So I have s plus 600, sorry for the funky pen, equals 900. Ooh, I got to get s alone. So I'll subtract 600 on both sides. Oops, there we go. That's better. And it looks like I get S equals 300. Oh, and that makes sense because we said student tickets sold was 300. Ooh, so how many adult tickets did we sell? Well, we can take this lovely guy and plug him in. So let's plug him in. I'm going to have A equals -S, and we just said that S was 300. Oopsie, too bad I can't write very well. Just kidding. I got you guys. So we have 300 plus 450. And of course, 300 plus 450 is 150. Oh my gosh, we just verified it algebraically. So even the algebra told us that we must have sold 300 student tickets and 150 adult tickets in order to have made $3,000. So what we've done here, we've done something very special here. The two graphed equations share a relationship between quantities, right? There's a relationship between the number of student tickets sold and the number of adult tickets sold. So when we graph the two equations, we're describing the relationship of each. So each equation describes that relationship between the number of adult tickets sold and the number of student tickets sold. Now, in one of them, that relationship was defined by the cost of each ticket and the total amount that we were collecting on it, right? But the second relationship, the second equation, is defined by the total number of tickets sold. So the two equations together form a system of linear equations. Notice how it's bold. This is one of your key terms. When two or more equations define a relationship between quantities, they form a system of linear equations. So they both were using the same quantities, but in different ways, and that's a system of linear equations. So guys, as always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, talk to me and let me know. Otherwise, I'll see you later. Bye.